G'day team, welcome back to another video. So today we're actually going to be starting a new topic. So we're actually going to start looking at growth and decay, looking at exponentials and logarithms, okay? But before we start attacking things like that, we need to make sure that we're all over our index laws, expanding and factorizing using index laws, things like that. So we're taking it right back to the start and we're going to build our way back up. So today I want to start looking at the index laws. So there are a few that I want you guys to have a look at, and using these is really important in more advanced modeling and calculus. So law number one, most of these are when we use the same base. So if we have a to the power of m times by a to the power of n, then we add the indices together. If we have a to the power of m divided by a to the power of n, we subtract the indices. If we have a to the power of m to the power of n, then we multiply the indices. Now if you have a times b all to the power of n, then both a and b must be to the power of n as well. Okay, so then 5, so a divided by b, same thing, so a divided by b to the power of n, both must be to the power of n as well. Anything to the power of 0 is equal to 1. And then we have negative indices as well. So a to the power of negative n is equal to 1 divided by a to the power of n. And 1 divided by a to the power of negative n is equal to a to the power of n. Now just a quick thing as well. Any number to the power of negative 1 is 1 divided by that number. All right, so there are our laws, quick snapshot, but we're going to jump straight into some trickier examples of using these laws. All right, so we've got a couple of examples to start with. So write in simplest form without brackets. So if we have a look at a to start with. Now, remember our distributive law, everything in the brackets must get hit by this power. And when we're putting powers to another power, we must multiply. So to start with, we've got 3, so to the power of negative 2. Remember, if there's no power written, then it's to the power of 1. 1 times negative 2 is negative 2. Then we've got y, but that's to the power of negative 1. So negative 1 times by negative 2 actually gives me positive 2. Okay? Now, same thing with z. Z to the power of 2. 2 times negative 2 gives me negative 4. Now, we often will try and write these expressions without negative powers. So we're going to get rid of those now. So remember, if we swap the numerator to the denominator, we also have to change the sign of the index. So the only positive index there is y to the power of 2. All right, and that is all over 3 to the power of positive 2 because we've changed it over, and z to the power of positive 4. All right, so we're nearly there. So whenever we have numbers that we know how to solve, it is best to solve them. So we all know 3 squared is in fact 9. So our simplified version of this expression is y squared divided by 9 times by z to the power of 4. Okay, let's have another go at this one. All right, so if you see a negative at the front, make sure you attach that to the number. It makes it so much easier to calculate. So we've got negative 4, all in brackets to the power of 3. Now it's really important that that negative goes in there, all right, because depending on if the power is odd or even is whether or not the negative stays, okay? Now we're looking at that b term, so we've got b, and then we've got to the power of 2, so we've got 2 times 3, which is 6, c to the power of 3, and a to the power of 3. And then we've also got a cubed on the bottom already. All right, so 3 times 3 is 9, so we've got a to the power of 9. All right, negative 4 to the power of 3. Because it's an odd power, the negative stays because we've got an odd amount of negatives. So we've actually got negative 4 cubed, which is 64. Then we've got b to the power of 6, c to the power of 3. And now we've got 2 same bases with a's. So we have to use our subtraction law. So we've actually got a to the 3 minus 6. minus 9, sorry. Getting ahead of myself. All right, negative 64, b to the power of 6, c to the power of 3, a to the power of negative 6. So 3 take away 9 is negative 6. Again, we don't like the negative power, so we're going to write that on the bottom. So all of these have positive powers, so they stay. Our negative power will jump to the bottom and change sign. And it is as easy as that. All right, there's 2 examples. So then another couple of examples right without the negative indices. All right, so we're going to focus on this one first. So what I like to identify where my negative indices are. So I've got a negative indice here, here, and here. So we know these 2 are going to jump to the bottom and this one's going to jump to the top. So we're still going to have, accidentally undid, we're still going to have our fraction bar. So on the top, P and F are actually moving to the bottom, so we're only going to be left with C. So we've got C squared, and then we've got this C to the power of negative 3. So if we bring that up to the top, we've got C to the power of 3. Now, if we're looking at the P's and the F's, P's first, so P on the bottom here, times by P squared, that's our P to the power of negative 2 coming to the denominator. And then we've got times F squared times by F to the power of positive 1 because we've taken this F to the bottom. Now we use our summing of index laws just to simplify. So C to the power of 5 because we add the indices all over P to the power of 3 times by F to the power of 3. Okay, simple as that. All right, last example, we'll do it nice and quickly. So we've got our distributive law, so 4 to the power of 2, everything gets hit by this power. C to the power of negative 6, negative 3 times 2, and B to the power of 4. Now, 4 squared, we know how to do, that is 16. C to the power of negative 6, that's a negative indice, so that's going to actually go to the bottom. So we've got C to the power of 6, and B to the power of 4 remains, and that is as simple as it gets. All right, hopefully this has helped you a little bit with your indice laws, negative indices, and hopefully you're keeping up, and we will keep developing these skills further on in the next video. See you then.